Welcome, students, to your first preview video lesson. You should have this packet right in front of you, which is your preview video notes. You're going to get one of these about every 3 weeks with each new chapter that we are doing. Just to give you a quick rundown on how to read the calendar in class. This was the activity that we had in class. A day or B day, same activity, 2 different days. In class, we had a short introduction to our algebra skills. And then it says here, your homework is this preview video, lesson 1.1, graphing of lines. And that homework preview video is in preparation for the in-class lesson in the next period. So this preview video is preparation for this in-class lesson the following Monday and the following Tuesday, A or B day. I'd like you to flip this preview packet lesson to this page. Just a quick rundown of how this will be graded. You're going to get 1 point just for noting both the time and location that you are watching this video. 1 point, you need to either have a parent, a teacher or guardian, or a librarian, if you're in the library, sign off that these videos were witnessed taking while you're watching the video. That's 2 points. And then 8 points for these 4 items. 1, you need to take detailed notes. You need to have evidence of work if there's a problem that requires work. Diagrams should show evidence of what's called brain and hand techniques. We'll be talking more about that in class. You should, any calculations, if you touch a calculator, you need to write down the calculations in the margin. Also show any algebraic work that you do, so solving for x. Basically, all the notes need to be filled out and complete. If you have all of these items, that's 8 points plus the 2 points, 10 points. These will be checked at the beginning of class each time you arrive to class. So we are going to work on our preview lessons for lesson 1.1, graphing of lines. This needs to be completed prior to class on August the 20th if you're A day, or August the 21st. Please at this time note where you're watching this video, on the smartphone, in your car, on the way home, or whether you're at home, or whether you're in the library or the teacher's room. Also both the date and time. When you are finished, a parent, guardian, teacher, or librarian should sign off here. Also make note that you should turn off all distractions. So if you have Facebook pulled up behind this video, close it. Skype, YouTube, if you have someone playing Xbox next to you, if your phone's set for receiving Twitter feeds, if you have a TV on, I need all those distractions turned off. The only thing I want you doing right now is focused on this video and the notes. All of the distractions turned off. We're always going to start each video with a review. So as a quick review, we're going to review using radicals and solving for x. Let's do this together. When you multiply radicals, you multiply the outies, I call those the outies, and the inside. Please draw those arrows, the outies and the innies, kind of like belly buttons. In this case, 2 times 5 is going to be 10. And then we have here 5 root 6 times root 3, that's going to be root 18. We can simplify here because we have 10, and this is also going to be root 9 times 2. 9 is a perfect square, so it gets out of jail. It has a change of heart. So the final answer is going to be 3 times 10, which is 30, root 2. Hit pause And try this one on your own and then check your answer. Okay, welcome back. Let's take a shot here. It's going to multiply the outies. 2 times 3. And multiply the innies. Root 5 times root 5 is root 25. 2 times 3, of course, is 6. Root 25 is a perfect square, so it's 5. The answer is 30. When you add radicals, it follows the same rules as variables. You can only add a like kind. So here we have a root 3 and another root 3 and a root 2 and a root 2. So we can only add a like kinds. So I'm going to circle this. So I have 4 minus 9. That's 5. And then the root 3's are just like x's. You leave them alone. And then here we have 6 plus 7. That's positive. 13. Root 2. And 4 minus 9, since 9 is larger, that means that is negative. That is as far as you can simplify that radical problem. Solving for x. Here we have a fraction, and on this side we have a whole number. The simplest way to deal with this is change all whole numbers into a fraction. We're going to do that by putting it over 1. Now that we are done with that, we can cross multiply. So I'd like you to put your pen on 96, draw an arrow, and then put your pen on x plus 18 and draw an arrow. We're going to cross multiply. So we have 96 times 1 equals 4 parentheses x plus 18. Please do not do the distributive property in your head. Always write this out. So 96 times 1 is simply 96. Now we distribute. 4 times x, of course, is 4x. 4 times 18. 4 times 8 is 32. Carry the 3, and that's, 32. So we put the 2 there, carry the 3, that's 72, and that's plus. Now we're going to solve. Minus 72. 6 minus 2 is 4. This is 24 equals 4x. We divide by 4. And of course we get then x equals 6. Those are the review of the basic algebra skills that you need for this class. Now we're going to talk about graphing of lines. Graphing of lines is one of the most important algebra skills. Hopefully you were introduced to this in your algebra class, so this is a review. When do you use graphing of lines? Anytime you do any kind of projection, like stock projections, accountant projections, scientific projections, anything that requires a graph of any kind, you're going to use equations of lines. Even equations of lines factor in when we're dealing with sports and sports angles. Any kind of grid system, you're going to be using equations of lines. We're going to review a few main key ideas that we use in equations of lines. The first is the concept of slope. In slope, slope is the tilt of a line. And in slope, there's two components to slope. One is the upward motion, of course, which is called the rise. And two is the horizontal motion, which is called the run. Now, on a graph, positive slope is any graph that tilts upwards from left to right. That's going to be positive. From the left side to the right side. That's how you read a graph. Which means that a negative slope is going to go down from left to right. That's negative. Zero slope. Now keep this in mind. Slope is rise over run. So zero slope happens when there's a zero in the rise. There is no rise. With that understanding, zero slope, since there is no rise, zero slope is going to be a horizontal line. That's not the same as no slope. Horizontal line is zero slope. Not to be confused, remember slope again is rise over run. When you have a zero in the denominator, that is impossible. That is what's called undefined. So no slope is also undefined. That's if you have a zero in the denominator. Well, in this case, zero in the denominator means there's no run, there's no horizontal motion. So if there's no horizontal motion, an undefined line is a vertical line, also known as no slope. Do not confuse that with zero. Horizontal lines in equations is anytime you have y equals, for example, 2, that will be a horizontal line. I'll show you how to graph that in just a moment. A vertical line is any x equals any kind of a number, we'll say -4. That is going to be a vertical line. I'll explain why in just a moment. We're going to start by reviewing the most important style of graphing, which is the slope-intercept form of graphing of a line. You are familiar with this because it's called y equals mx plus b. In this case, the m is the slope, and the b is what's called the y-intercept. That's where it crosses the y-axis. So let's take a moment and see how can we graph this. Step number 1, we are given y equals 2/5 x minus 5. I'd like you to write out y equals mx plus b directly underneath that. Then your next step is to identify your intercept, which in this case is -5. That is the y-intercept. And your slope, notice your slope is positive, is 2/5. So to graph this, step number 1 is look at the slope. Determine whether the slope is positive or negative. It is a positive slope. So I know right now my line's going to go up from left to right. And where it crosses the y-axis is at -5. That's the y-intercept. So I graph, this is the x, this is the y. I start on the y-axis. So I go to the y-axis and I put a plot at -5. Now my slope, my rise is 2, my run is 5. So I go up 2, 1, 2, and I'm going to run 5 to the right because it's a positive slope. 1, 2, 3, 4, 5. I could have also gone the other way. I could have gone down 2 and to the left 5 and gotten the same thing. Now once you graph a line, I always want you to label your lines, please. So this was the line y equals 2/5 x minus 5. What I'd like you to do is, using this as a model, I'd like you to hit pause on the video, and I'd like you to attempt to graph this on your own. Take about a minute or two, and then when you are done, turn the video back on and check your work. All right, welcome back. Let's see how you did. Step 1 was to write y equals mx plus b. We identify our y-intercept first, which is going to be positive 4. And we identify our slope, which is positive 3. Now, whenever you have a whole number for slope, it's always very important that you remember to put it over 1. That way you can easily see rise over run, that your run is 1 there. It's not 0, it's 1. So to graph this, you should have started on the y-axis at positive 4 and plot up. That's your y-intercept. We know it's a positive line, so it's going to go up from left to right. So I rise 3 and I run 1. I also could have gone down 3 and over 1 this way. Again, it's a positive line, so we're going to go up from left to right. That is slope-intercept. The second form is what's called standard form. Standard form is when you have something in front of x plus or minus something in front of y equals something. It's also written like this: ax plus by equals c. That's called standard form. There's 2 ways you can handle standard form. The first way is to change it back into slope-intercept. So let's try that. Slope-intercept form looks like this: y equals mx plus b. So you can see that you need to get y by itself. So if we were working with this equation, 3x plus 4y equals 12, to get it into y equals mx plus b, I'd like you to box the y. You want to get y all by itself, so you need to clear everything else. So we're going to do that through these steps. Step 1, we're going to minus 3x, minus 3x. We end up, I'm going to bring it over here with 4y equals, bring the x first, negative 3x plus 12. Now we're going to get rid of the 4. These cancel, and your final version is going to be y equals negative 3/4 x, and 12 over 4 is plus 3. Another way you can do this is using what is called the intercepts. Intercepts, the x-intercept and the y-intercept. The x-intercept is when y is 0, what is x going to be? And the y-intercept is when x is 0, what would y be? So we put our equation here. It's 3x plus 4y equals 12. So let's do our first one. If we put a 0 into the y there, we basically get rid of all of this. So now we have 3x equals 12. You divide by 3, and we get x would equal 4 there. And in this one, we're going to put a 0 in the y. A 0 in the x. We say goodbye to this to solve for y. So we have 4y equals 12. Divide both sides by 4 mentally. And we get y equals 3 in this case. So now to graph these, we're going to graph them both ways. I'm going to graph using the intercepts first. So 4, 0 looks like this. I go over 4, and I go 0 up or down. So that is my intercept, 4, 0. And then 0, 3, I don't go anywhere left or right, but I'm going to go up 3. This is 0, 3. That's the y-intercept. And then you take your line through both of those. That's graphing by the intercepts. Now let's take a look if we were to graph this by y equals mx plus b. Our intercept is positive 3, so we plot that. That's right there. And then my rise and my run, my rise is negative 3, my run is 4. I know it's a negative slope line, so it's going to go down this way. So there's 2 ways I can do this. I can rise 3, 1, 2, 3, and then go over 4. 1, 2, 3, 4. That's the slope, negative 3/4. Or I could go down 3. 1, 2, 3, and over 4. 1, 2, 3, 4. Notice it's the same line. So you graph by intercepts or change it to y equals mx plus b. What I'd like you to do now is I'd like you to attempt, hit the pause button, and I'd like you to attempt graphing this problem either by changing it to y equals mx plus b or by intercepts, your choice. Do this now. Okay, welcome back. Let's check to see how you did this. I'm going to try with the intercepts first. So I put a 0 in the y to get my x-intercept, or I put a 0 in the x to get my y-intercept. If I put a 0 in the y, we simply say goodbye to it. So I end up with 6x equals 18. And that's 18 divided by 6. My intercept is 3. And then here, if I put a 0 in the x, I say goodbye to it. I have negative 2, y equals 18. I divide both sides by negative 2. I end up with negative 9. I'm going to graph those two. 3, 0, so we go over 3, 1, 2, 3, but go up and down 0, so that is my x-intercept. My y-intercept is 0, negative 9. And those are my two intercepts. Or I could have done this. I want to get y all by itself, so I subtract 6x both sides. I end up with negative 2y equals negative 6x plus 18. Divide each side by negative 2. And I get y equals negative 2 goes into negative 6 3 times, positive, plus, excuse me, that's going to be negative, minus 9. Let's try graphing this, y equals mx plus b. Our b is negative 9. Well, look, that's already our first intercept. And our slope is going to be 3 over 1. So our rise is 3, our run is 1. And I know it's a positive line. So I can go up 3, 1, 2, 3, and over 1. Go ahead, or I could have gone down 3, 1, 2, an imaginary 3, and over 1. Either way. I'm going to go ahead and graph that line, and look, it actually goes through our second intercept. That is 6x minus 2y equals 18. The last method, and the one you most likely do not remember, is something called point-slope form. Point-slope form looks like this. Y minus y1 equals slope x minus x1. Why is this called point-slope? Because we use it when you have a point, which is the x1, y1, and you have a slope, which is m. That's why we call it point-slope form. So it says right here, write an equation of a line that goes through the point 1, 3 and has a slope of -2. We're going to graph. It's actually really easy to graph this. So our point, our x1 is 1, our y1 is 3, and the slope, which is our m, is -2. Technically, -2 over 1. So to graph this, all we need to do is plot that point right here over 1, up 3. Always label your graphs. This is graph 1, 3. That's that point. And then our slope, notice it's a negative slope, so I know it's going to go down from left to right. So I'm going to go up 2 and over 1 to the left to make it tilt downward, or I could go down 2 over 1 to the right. I'm going to go ahead and graph this line through the given point and the slope. Now we want to write an equation of a line, so we're going to do that by writing this equation out. Now let's plug in our numbers. Our numbers here is y minus y1. So we're going to put a 3 right there. So we have y minus our y1 equals our slope, which is -2, x minus our x1, which is 1. Now we're going to change it to y equals mx plus b. We start by distributing. We have y minus 3 equals -2x. It's going to be plus 2. And then from here, plus 3, we add 3. So our final equation is y equals -2x plus 5. Let's see if we can't graph that and see if it's the same line. It says right here that our y-intercept is 5. Let's see if that's true. 1, 2, 3, 4, 5. Lo and behold, that is our y-intercept. And our slope is -2 over 1. So again, from that 5 down 2 over 1, up 2, to the left 1, again, it's the same line. So what I'd like you to do is first graph this line, hit pause, graph the line, and then plug it into point-slope form and find the y equals mx plus b version. And then start the video again. Welcome back. Let's see how you did. So it says write an equation of a line that goes through the point 4, 6. That's going to be our x1 and y1 and has a slope of 1/2. So to graph this, we're simply going to plot 4, 6. So we go over 4 and up 6. And our slope is 1/2. So the rise is +1, and the run is +2. And we're going to go up from left to right because it's positive. So we rise 1, go over 2, or we can go down 1 and over 2 this way. So we're going to graph that line, see what happens. A little off. Let's try that again. Now let's try point slope form. We're going to go y minus y1 equals slope x minus x1. So we're going to have y minus, our y1 is going to be 6 equals our slope and our x1 is 4. So now we distribute, and we're going to end up with y minus 6 equals 1/2 x minus half of 4 is 2. And now we're going to add 6 both sides. And our final version is going to be y equals 1/2 x plus 4. Now let's graph that and see what happens. Our y-intercept, y equals mx plus b, our b is going to be +4, which it is. And then our slope, rise over run, our rise is 1, and our run is 2. Same line. Or we can drop 1 and go over 2 this way. Please review these notes carefully and be prepared to do this in class.